Lesson 2. First, the 3D operations, kinematics, primitives, Boolean, and so on. Second, the 3D object decomposition and its model creation. Third, the purpose and meaning of snapping features. And fourth, practice. The 3D operations. The most common operations for 3D object modeling are the following. First, kinematics, and extrusion is the first of them. To model an object, we should define the plane sketch in 3D space in an arbitrary plane, the circle in our sample, and move it normally to its plane. As a result, we can obtain a cylinder surface. Bounding it by two planes like this, we can obtain the solid cylinder. Rotation, or someone calls it a revolution. There should be defined two lines in 3D space, namely revolution axis and generatrix. The revolution axis can have an arbitrary direction in space, and generatrix can have any shape, but cannot cross the revolution axis. In our case, we can also obtain the solid cylinder. Note please, the cylinder can be modeled by both kinematics operations. There are another kinematics operations that can be considered as a combination of the above described. Second, the library of primitives. The primitives are the very simple geometric objects with a number of geometric parameters. The primitives library contains such objects as sphere, parallelepiped, prism, cone, torus, and many others. Boolean operations. The main purpose of Boolean operations is to obtain a solid model on the basis of a group of simple geometric objects or primitives. There are several types of Boolean operations, and the most widespread among them are the following: Boolean adding or union, subtraction, and intersection. You can see on the slide how they work. The complex object decomposition. All the objects in nature have very complex form. The object decomposition is usually made by the user in his mind and precedes modeling. The complex object decomposition is the process of the model subdivision into the set of simple primitives and can be done in different ways. Let's consider a very simple example. The object consists of thick base with outgrowth and the whole. We subdivide the object into three primitives, say two parallelepipeds and one cylinder, A, B, C. Note, the composition can be done in the other way too. Then we model all the primitives either by kinematics operations or by using the primitive library, and finally, applying the Boolean union and subtraction, we can obtain the desirable model E. In the K3 system, all the described above features are executed by the set of appropriate functions. Let's create a cylinder by the extrusion operation. We should create before a planar sketch in the form of circle. Click the command Create Lines Circle and create the circle in the plane XY. Then click the command Kinematic Extrusion. Kinematic Extrusion. Then we should click the circle after the system request to mark the external contour of generatrix. And click Done subcommand of the extra menu at the bottom of the right-hand panel. Done. Do not remember, click Done subcommand anytime when you would like the system to know that you have finished selection. After all, we should type the cylinder height at the command line and press Enter button, or mark it by mouse as another viewing frame. The cylinder is modeled. Let's now create a cylinder by the rotating command. To create the generatrix, we click the command Create Lines Line and create the line parallel to coordinate axis Z. Then click command Kinematic Rotating and click the line after the system request. And then we should define the revolution axis. Note, to define revolution axis, it's necessary to define two arbitrary points on it only. We type in the command line 0, 0, 0, press Enter button, and 0, 0, 10, press Enter button. It means we have defined the line of an arbitrary length line on the axis Z. Finally, we should define the rotating angle, 360 degrees by default. Simply pressing Enter button. Okay. We have modeled two cylinders by two kinds of kinematics operations. In addition, let's consider the two following very useful functions in the kinematic group. First of them, the screw function. It allows the creation of spiral shapes. To illustrate it, let's create an arbitrary generatrix, for example, by the function create lines circle. Then we activate the function create kinematic screw. Let's mark the circle after the system request. Select an external counter of generatrix. Don't remember to press the down subcommand. Then we should define two arbitrary points of the revolution axis, 1 and 2. After that, we should define two values, say the height of one turn and the general height of the shape. Let's our shape have 5 turns. Therefore, the height of one turn is equal to 40 and general height is equal to 100. After that, we should answer the following question of the system: close up to body, yes or no. The system means if we would like to create a solid object or skin object. We answer yes. Look at our spiral shape, please. Okay. The next function is pipe. This function is very similar to usual extrusion, but the guideline in this case can have different form. For example, let's create the circle once again. Create a lines circle. Then we should create the guideline by spline function. Spline by spline. We will create non-planar spline. Therefore, we click the points of it in different viewing frames. The next step is clicking the function create kinematic pipe and marking the guideline after the system request. The guideline is our spline. Then we should click the generatrix, that is the circle, and mark the generatrix base point. The base point is an arbitrary point which is used to coincide generatrix and guideline. Then the last step is to define an angle of the generatrix orientation to the guideline local coordinate system. It can be varied but equal to 0 by default. And then we should answer the questions once again, and our pipe object can look like this. Object snaps are one of the handiest tools in the K3. Without them, you would have a lot of trouble doing even the simplest model precisely. The name object snaps means that mouse pointer snaps to object, or more precisely, it snaps to a specific part of the object. A line, for example, has 3 points that we can snap to. For example, to middle and to ending point. All types of object snaps we can find in the pop-up menu options on parameters. Okay. There are also some object snaps that are not precise. These allow us to snap to arbitrary points along an object. These would include nearest, tangents, and perpendicular, and to some extent intersection, and so on. For example, perpendicular. There are 2 different ways to working with object snaps: in running mode or invoking them individually as required. Running or object snaps mean that certain ones are turned on and running in the background. This means that they are available when needed in the middle of a command. To toggle running mode, we should simply press the button at the top of the left-hand menu. When running mode is active, the object snaps appears at the context-sensitive help, like this. Sometimes we may need one object snap that isn't one we have selected in running mode. In this case, we can turn on for one-time use. To do this, we can click the right mouse button executing the function. For example, we can select the needed object snapped and click it, for example, on object. You see. In most cases, we do not want to turn on all the object snaps while modeling, as we could accidentally snap to a point we don't want. For example, the ending point and perpendicular point could be very close, so we need to be careful when using perpendicular. And now, let's a bit training. For example, let's create some primitives, for example, a cylinder. We're snapping to ending points of this line and clicking the second base point of the cylinder and clicking the radius. And now we can see that the line coincides to the center of base precisely. Okay.